what to do. So again, cheesy Mahan, right? Cheesy teacher. This is my way of memorizing it. It looks like a hangman, hang person. The head, I said GCF, greatest common factor. So the first thing you want to do is always find out the greatest common factor, and I'll talk about that in a little bit. After you figure out the greatest common factor, you want to count how many terms are in that expression. So depending on how many terms you have, you will take one of these routes, right? So if there are 3 terms, you're going to do something that's called Xboxing, or your preferred method. If you have 4 terms, we're going to learn how to group. And if you have 2 terms, you actually have two pathways. I call it the dots, difference of 2 squares. I call it the doctica and soctica. Acronyms for difference of 2 cubes and sum of 2 cubes, and these are formulas. And I'll get to all these later. But overall, the biggest idea is pull out the greatest common factor, and whether or not it has the greatest common factor or not, you need to take one of these paths. And you should always check your work, and you want to factor it completely. Just because you factored it once doesn't mean that it's done. Now, I have these boxes here on the bottom. They're colored, and there's just a way to help you to memorize it. And then the back of the sheet is exactly that picture that I drew, but here it's written out in words. I said 1, 2, 3, 4, 5. So do whatever floats your boat, whether you want to remember it from the picture or you want to remember it like this way. And this is something that we'll get to next week to solve quadratic equations. All right, so let's go ahead and look at some examples here. So the first problem here says factor out 15a squared plus 6a cubed. So what we do is we're going to look at these 2 terms, and we're going to ask ourselves, what do they both have in common that they're divisible by? What does 15 and 6 have in common that it's divisible by? 3. So I see the number 3. So 3 is a number that they both have in common. And then I have the a squared and the a cubed. So remember, a squared is just a times a, and a cubed is what? A times a times a. What do they both have in common? How many a's? 2. So they both have a squared in common. So therefore, the greatest common factor between a squared and a cubed, between these 2, is going to be a squared. So it's the exponent with a lower number. So even though it says greatest common factor, students sometimes think they take the biggest exponent. You want to take the smallest one because that's what they have in common, right? They have 2 of them in common. So this is what we call the GCF, the greatest common factor between these 2. Okay, so that's pulling out the GCF. Now I'm going to put parentheses, and since there are two terms, I'm going to do blank plus blank. And the definition, what you're doing when you're factoring is the reverse of distributing. So up until now, for an example, up until now when I had 5x times 3 plus 7x, right? Up until now, when you see that, what do you normally do? We normally distribute, right? We normally multiply through. So if you multiply through, we get 15x plus 35x squared, right? This is what we normally do. However, what we're doing now is called factoring. So what factoring is doing is we're going to do the reverse. We're going to start with this, and then now we're going to factor it. So we want to factor it so it goes back to the things in parentheses. So what factoring means is you look at the 2 terms, you say what do they both have in common, right? What they both have in common. So in this problem, they both have what in common? Between a 15 and a 35, they have a 5 in common, right? And the x and the x squared, what do they both have in common? X, right? So kind of what we're doing there, I'm just doing a different problem here. And then I do blank plus blank, right? And then I ask myself, because I want to get back to this original one here, I say 5x times what will give me 15x? 3, right? 5x times 3 will give me 15x. And then I ask myself, what 5x times what will give me 35x squared?
7x.
7x, right? And therefore, I go back to its beginning. So factoring is really just the reverse of distribution. Instead of getting rid of parentheses, you're creating parentheses. You're creating things to multiply by. These are called factors. So here, 3a squared times what will give me 15a squared? 5, right? 3 times 5 will give me 15. And there's a squared. 3a squared times what will give me 6a cubed?
2a.
2a, right? Because 3a squared, 3 times 2 is 6. A squared times a. Remember the laws of exponents? When you multiply, you add the exponents. 2 plus 1 is 3. And that's how we get that. And this is what we call the factor form of this. And you can always check your work. Just like this person says, remember, you can always check your work by using the distributive property to multiply through the parentheses to see if you get your original expression. So here, I can multiply this through, and I go, hey, what do you know? You get back to this. All right, I'm going to skip forward to number 3 now. So number 3, looking at this, how many terms do we see? How many terms? 2. So terms are separated by adding and subtracting, right? So here, let me give you guys a chance to go ahead and pull out the GCF, whatever the GCF is, put parentheses down, and then since there's 2 terms, you're going to do blank plus blank. So we have a u squared. So because u6 times u squared, you add the exponents, or you think of it as 6 u's written out, then 2 u's written out. That's a total of 8 of them. That'll give me the original value. How many more w's do I need? Do I need any more w's? No, right? There's enough w's. w5, w5. What else do I need to put here?
Y squared.
Right, y squared. So double check your work. This multiplied by this, if I distribute it, you should get its original value here. Right. Last but not least, the second blank. To go from the GCF, I need to multiply by something to get me this 30 u6w6. What do I need to multiply by?
5w.
5. Okay. How about u's? Do we need to put any more u's? No, right? It's already u6 and u6. It's already there. And I heard you say, Tristan say we need a w as well. Because w5 times w, that's a total of w6. And that's the answer for this. Does anyone have any questions on that?